Hi guys, I'm Ernest. Welcome to our channel of Sciences and Mathematics. Our discussion for today is going to be the precipitation reaction in salt formation. This is one of the ways among others that we're going to look at in trying to figure out how we can be able to obtain salt. Now there are other processes that you've already discussed, maybe in form of mentioning them, like the neutralization reaction that we talked about when we were discussing about the concept of acid-base titration and maybe an acid metal reaction. So for today, basically, we're going to look at this particular concept, and it's going to be relevant in the sense that precipitation reaction forms the basis for us in trying to identify elements present in a solution, especially in chemical analysis. So in that case, thank you and welcome. So in trying to figure out how we can be able to define these precipitation reactions in salt formation, we're going to look at the concept that we have already discussed, and acids, bases, and salts, and try to define basically what a salt is as an approach in trying to figure out how this process of precipitation takes place. Now we said that salt is an ionic compound that is formed when a cation that is derived from the base combines with an ion that is derived from the acid. And when the two combine, they form what we call a product that we refer to as a salt. So in this case, we're going to see that the specific combination of an acid, a cation from a base, and an ion from an acid forms what we call a salt. And as well, we can form salts from or maybe when hydrogen ions in an acid are replaced wholly or partially by a metal, an ion, or ammonium ion, either directly or indirectly. For instance, we are going to give an example of, let's say, this is an acid, HCl. You see this one in ionic form is going to form these particular ions. So this is HCl acid in aqueous form. It's going to form these ions which are present. Of course, there will be others like the one of OH that will be present because of the aqueous nature, but we're basically going to look at the ions of our interest. So in this case, from the second statement that I've given, I've said that salt are formed when hydrogen ion in an acid are wholly or partially replaced by a metal ion or ammonium ion, either directly or indirectly. Now, for instance, this refers to the concept whereby we have an example like sodium, which is a metal ion, or an ammonium ion, which is basically a positive. And then 8 of the 2 can replace this acid from hydrogen ions from an acid, either partially or wholly. Now, for instance, if we had sodium ions reacting with or replacing hydrogen ions in this particular case, then we're going to form a sodium chloride, and basically this is going to form what we call a salt. Now, in this case, we can have an example of ammonium ion that is replacing an acid from a reaction by having ammonium hydroxide reacting with HCl to form ammonium chloride plus water. So this is one of the methods of preparation of salts, as we said, which is basically an acid-base reaction. And in this case, if we're trying to figure out how we can be able to represent this, then the ammonium ions are going to replace the acid, the hydrogen ions from the acid to form ammonium chloride. Now, in this case, there are several ways in which we can be able to achieve different types of salts from acids, whereby we'll have a parent acid that is reacting maybe with a base or a metal, and the replacement that we have talked about is going to occur, and there's going to be formation of a salt. Now, for instance, if we have a salt of we want to form a salt of ammonium sulfate, and this is with a combination of a parent acid together with a base that consists of a positively charged ammonium ion that is going to form a sulfate. Now, this is going to be this is ammonium ion combining with a sulfate. This is just an ionic form of that equation representing the sense that maybe this can be a sulfate, this can be an hydroxide, etc. So it's combining with the sulfate and forming ammonium sulfate like that. So basically that's going to form a salt, which is ammonium sulfate. We're going to look at different ways in which we can identify the product that is formed, especially on the concept of solubility and the solubility curves. So basically I'm just going to mention that specific salt, and we're going to determine later whether the sulfate is maybe soluble or not, in order for us to allocate the status of a precipitate or not. So basically the concept here is a combination of a parent acid and that specific cation in order to form what we call ammonium sulfate. Now in any case, there's different acids that we can give an example. For instance, I've said about sulfuric acid. This is a sulfuric acid. Now suppose we had a hydrochloric acid, then it's going to form a chloride. Nitric acid, it's going to form a nitrate. And then sodium hydrogen carbonate is going to form carbonic acid, etc. So there are different states in which we can be able to maybe refer to salts. And in some cases, especially in the concept of electrochemistry, we talked about electrolyte. And this basically was an ionic compound which infers that it's conducting electricity. Now, salts in form of molten states are basically electrolytes. So whenever we're trying to compare the properties of salts and trying to see whether it's conducting electricity or not, then we're going to remember this statement that I've just provided in between specific discussion. So going to our topic, as having defined the concept of a salt, then we're going to look at a precipitation reaction, an example of precipitation reaction that is going to lead to a salt formation, which is going to represent a wider range of some of the reactants and the products that are going to be formed, or an example of a precipitation reaction that we're going to encounter maybe in one way or another during our discussion. So precipitation basically is the process by which two salts react to form an insoluble salt and a soluble salt. And for instance, we can have an example whereby we are having lead nitrate that is reacting with another salt, sodium sulfate. And this is going to result in the formation of lead sulfate. Basically, we're going to see that there are radicals which are going to be exchanged. Therefore, we're going to have lead sulfate plus sodium nitrate. And this basically is and having discussed about the concept of solubility, or mentioned the concept of solubility later, we're going to see how these specific salts are going to be formed. But basically the precipitate that we are talking about here is an insoluble salt that basically is going to be formed from the reaction between two salts which are reacting. So this entails to the concept of exchange of these specific radicals that I've talked about. And from this we can be able to have an ionic equation, having discussed from some of our topics about the concept of representing stoichiometric equations in form of ionic equation. So we're going to see that this reacting species can be able to be prepared in solution form. This is going to form a solid, so basically which is an insoluble salt, which we are referring to as a precipitate, and this is soluble. So this is one of the examples of a representation for precipitation of reactions that is resulting in the formation of a salt. And we're going to have this one represented as an ionic equation by trying to write individual ions. So we're going to have lead plus nitrate. So these are two moles of nitrate plus sodium plus sulfate. This is a 2 negative, so therefore we're going to have a 2 there. And then we have formation of a product, lead sulfate. So as we said in stoichiometric equations, for solids, liquids, and gases, we're going just to represent them in those specific states, and trying to figure out the ions present in the product side. We're having sodium and then the nitrate given us that. But for us, in any case, of course, I did put 2 here. For us to write a stoichiometric equation for this specific ionic equation, we're going to have 2 for sodium, and then for the nitrates 2, so that we can be able to represent this one as this. And then this is going to be 2. So those 2 equations are balanced. And therefore, I'm trying to figure out the ions which are not taking place in the reaction, which we refer to as spectator ions. The nitrate ions have maintained their status, so therefore they are spectator ions. Together with these are going to be 2 from this, so therefore together with the sodium ions are spectator ions. Therefore, the overall ionic equation for this precipitation reaction that are leading to formation of a salt is going to be lead ions plus sulfate ions, and this is going to form lead sulfate. So therefore this is the overall ionic equation for that specific formation. So we can have different types of reactions that of course we are going to follow this specific example in trying to represent precipitation reactions for formation of salts. And as we have said, this is one of the ways in which we can be able to determine the presence of these specific salts in solutions, as we're going to see later, because they form characteristics, maybe colors or precipitates. Another example is the one that we can have silver ions reacting with the chlorine ions to form silver chloride. And this is going to be a white precipitate. So in reacting a chloride with a silver, maybe if we are suspecting the presence of a silver ions, then we're going to find out or get that this is forming a white precipitate. Especially maybe if we had a reaction between the silver nitrate, this is a silver, sorry, this is a silver nitrate reacting with a common salt, or maybe sodium chloride, and then we are going to have this formation of a silver chloride plus sodium nitrate, which is aqueous. So in this case, this equation, I think it's balanced. So therefore, we can have an overall ionic equation from this specific representation that is going to show how we can be able to achieve these salts from the reaction of these 2 soluble salts. So therefore, this, among other ways, is a method that we can be able to use in preparation of salt, apart from the neutralization that we talked about, an acid metal reaction. So I hope that this among others, the ways in which we are going to discuss these methods of salt preparation, now that we have mentioned about precipitation being an important reaction, especially in identification of elements. So I hope this is clear. That is it for today. Bye. God bless.